Hello everyone, sorry for being late, especially to former speakers. So today I prepared a short talk about Lightning Network. This is something pretty new. Basically, Lightning Network currently is not deployed to any major network like Bitcoin or Litecoin, for example. However, many people says that this is a solution for current problems which Bitcoin has. I'm not an expert in Lightning Network. I decided to just learn about it, and now I would like to share my what I found about it. Short bio about me. I'm mentioning this because you need to be careful when you're joining this meetup, because after last meetup I actually end up being employee of company which was introduced also here, so be careful. you can have similar story. In case you would like to approach me, you can find me on standard Gmail address and on Steemit via AKA Noise. Okay, so how to build own Lightning Network. Basically, funny thing is you do not need to actually code to build something like Lightning Network. So I built my own Lightning Network using few pieces of papers, table. I asked my wife to help me. That was the most difficult part, and some time. Basically, but first, why Lightning Network is needed, right? For example, even today I made the transfer from Polish exchange, BitPay, to another exchange, and I did that in like 1 AM, and I checked this few minutes ago, and this transaction is still not confirmed because we have a problem with confirmations, and Bitcoin is still a small thing right now. If 7 billion people would use Bitcoin every day with only 2 transactions per day, we'll end up with 24 gigabytes blocks. That would translate to those values, what would be completely insane and dangerous, and that would kill the spirit of Bitcoin, because bigger blocks means centralization. Very few full nodes, almost no miners, and if you have so big blockchain, it's impossible to go from the beginning to the end. So that would actually be very centralized database, not much different from Visa or another solution. Okay, so this is very interesting diagram, and to actually understand how Lightning Network works, we need to understand this diagram. It's really complicated when you take a look on the first glance on that. So I try to read about it, I try to watch different videos, lectures, and so on, and I end up doing something like this. Piece of paper, and I create manually transaction one by one, and I try to hack transaction of my wife, and she tried to hack my transaction. We tried to cheat only on the here, right? And actually that was pretty fun. And one disclaimer: I'm not 100% sure that this will be implemented in this way, the real Lightning Network. I will try to explain you my understanding of the whole network. But first, to understand everything, we need to understand a few very simple building blocks, because those really complicated transactions are actually made from very simple building blocks. So, one by one, how simple transaction can be represented. Something like this, when we have information from who basically spent those money, the amount, where those money are transferred, and also what is required to actually be able to spend those money from this account, right? In most cases, this is like private key, so basically Bob's signature. But to commit this transaction needs to be signed by Alice because Alice is owner of this account. So he will be later signature of the Alice. Another type of the transaction, also very simple one, is transaction with two outputs, right? We can. This is like a chain. So Bob right now have 10 bitcoins, and Bob can spend those 10 bitcoins at once, sending those 1 bitcoin to Carol and 9 bitcoins to David. So far, very easy. Of course, also need to sign this. Okay, next thing, multisig. Do you know what the multisig is? But in few words, multisig is very fancy SIG address. Basically, this is address with certain properties. Basically, multiple people can be the owner of the account. The most basic one is that two people need to sign one particular transaction to spend any money from one particular account. Basically, there can be many different configurations, like n signatures from n possible. But the very simple is we will basically use here one of two multisig. Only one signature will be needed to spend those. Am I right? Not always. We'll be back to that later. So, but basically multisig. So in that case, someone sends 5 bitcoins to one account which belongs to Alice and Bob. And as you can here, we know that this is 2 of 2. In multisig because two signatures are required. And later, for example, someone wants to spend 5 bitcoins and send those to Carol from this one common account. And as you can see, Bob is preparing this transaction because we have to remember one thing, and this is tricky. When you have two parties like Alice and Bob, on private key on account, there's no such thing like they do something together. No, someone always has to be first, right? So the thing is, Bob can prepare a transaction like a framework, sign it, and send this transaction, not confirm it to Alice, and Alice can sign this later and broadcast to the network. And we will see similar actions later. So this is important. Yes, and in that case, Bob prepared this transaction. He already signed it, and he prepared this transaction that Alice also needs to sign this later, just before the broadcasting. Okay, so that is the multisig. Next thing, time lock. Time lock is something pretty new. Basically, we can distinguish two kinds of time locks, relative and non-relative. Not relative is that money can be spent after a particular date or after a particular block number, or relative that after 1,000 blocks after this transaction. And we will need to, this example, the second type of time lock. So imagine that someone sent 10 bitcoins to Alice, but Alice will not be able to actually spend those 10 bitcoins immediately. She will need to wait 1,000 blocks. So this will not work until this will happen. Right? Okay. Okay. And another thing, hash values and secrets. There can be another type of transaction in Bitcoin network. where to actually spend money from the account, you need to signature, but also a secret. You can treat this as a password, as additional variable. This can be very handy, as we will see. So just to explain this, here we need to, of course this will be like prepared hash, and here the secret will need to be provided to actually broadcast proper transaction.
So Alice is creating password for herself or for someone else?
Basically, the rule is that it always depends who creating the transaction. So in that case, someone could create the transaction and do not tell Alice a secret before something else happens. Alice could also create a hash of own password. This can be useful in some cases, but basically this is a tool and can be used in many different ways. Okay, so...
Oh, sorry, I'm confused. So I can send Bitcoin to someone and he will not be able to spend it until I give him the password?
Yes.
Okay.
Will those Bitcoins be still on my wallet, or where will it be?
Like exactly the same place as any other Bitcoin. There's no in the network. You will not be able to actually spend it. It will be similar case like if you would lost your keys.
Okay.
You do not fulfill all permissions. Right. Okay. So that was building blocks. And another very important fact: transaction types can be combined. Right. And what does this mean? Basically, probably you heard that. Right. That Bitcoin is programmable money, and this is an example, right? This is a pretty complicated transaction, which combine all those basic building blocks which we described earlier. And basically, this transaction in the Lightning Network is considered as a commitment transaction. This, like, you can consider this as a framework for commitment transaction. So we'll try to very quickly go through this. So as you can see, this is simple multi-sig account. So we are spending 10 bitcoins. 6 bitcoins we are sending to Bob. This is like easy part. At the same time, because this is multi-sig, Bob already signed this. He is really interested to receiving those 6 bitcoins, right? Also, a signature of Alice will be also required. But before that, we are curious what will happen with the rest of the bitcoins, and the rest of the bitcoins can be sent back to the original account. And additional requirements can be spent. Interesting fact, we can have logical order that one of those two things can happen. Okay. And right now we'll try to explain how this will actually work. And this is tricky. But first, overview. Basically, if you think about Lightning Network, I will try to describe this a little bit more. Whole magic in the Lightning Networks is about creating channels. If I know that I will transact with someone very often, I can create a channel, and only first transaction hits the blockchain. What basically this means that later we can do as many transactions as we can without any fees because this will be completely off-chain. We do not need to have internet connection later, just we need to have connection to each other. So imagine, for example, a scenario that you have a car like Tesla, you go through the city and there's a red light, and below the car there's some kind of charger, and just when you are on the red stop, this car can be powered, and at the same time transactions, thousands of transactions can happen without actually hitting the blockchain, and everything can be really, really secure, and I'll try to show why is that. But first, how we create a channel. There are a few different types of channels. I will describe today only once. That was the reason why why this introduction part one. So at the beginning, imagine that, for example, I have like a common account with my friend, and we commit at the beginning 5 bitcoins. And if after one transaction I will have 6 bitcoins and he only 4, this means that transaction happened, 1 bitcoin was sent to me, right? So this is this part. Basically, transactions here will be almost invisible because we will not see transactions. We'll see always end result of the transaction, only balances, right? So 6 and 4. But there is a problem with that flow. Basically, this cannot be performed in this order because, for example, if we will have this transaction broadcasted to the network, and I don't know, maybe if we would lose connection, basically we would end up with 10 bitcoins locked up forever because I would not have a way to contact, for example, another user. So that would not be secure. So basically we need to do something different. First, we'll prepare those transactions, and when we will exchange those commitment transactions, we will broadcast opening transaction to the network. This is tricky part. Basically, okay, so what did those commitment transactions actually do? They are there to make sure that those money at the end will be spent correctly. So those commitment transactions, one belongs to Bob, another belongs to Alice. So if Alice will disappear, Bob needs to have at least one commitment transaction to be able to broadcast. And the same happened for Alice, right? So first, they prepare commitment transactions. They exchange everything, signatures and so on. And if they know that they have proper commitment transaction, they can open a channel because they are sure that those funds will be spent without any problems. Okay, what later? Basically, those are end results. Funny thing is that this can never happen if we are happy with the current state of our channel, because channel can be open forever, and actually channel is closed only when something bad happens, when someone wants to cheat or we maybe lost connection. The only way when we need to close channel, the only time when we need to close channel is those unfortunate cases, and only then we need to pay a fee, right? So we can make millions of transactions and only pay one fee. So basically this means that next transaction basically is new version of commitment transaction. What is related with the new possible outcome. The same happened one more time, the same happened one more time, but because basically we do not have to care about those things in most cases, only once when we want to close channel. Basically, Lightning Network is so fast because we can create new transactions just like that, just by creating those commitment transactions. And we just need to exchange those transactions with each other. We do not need to send this in any place. We can make 1,000 transactions per second. Basically, limitation is our hardware. Okay.
But these transactions are Bitcoin transactions, or you're talking about some non-Bitcoin transactions?
Bitcoin transactions. Basically,
so,
Lightning Network
is
is
transaction. You just send it to your partner, and you don't broadcast it to the network. You mean?
This is like check. I can prepare a check, and whenever you would like to show this to proper authority, and in that case, authority is the blockchain, then you will end up having those bitcoins at your address. So basically, Lightning Network is a clever way of doing transactions, and this can be implemented on top of any blockchain which supports proper types of transactions.
So if I understand it correctly, it's just like this pre-committed transactions are just basically any transactions that are signed in a way that allows you to produce the valid transaction at the end, which is this end result that's like later committed to the network, right? Because
The transaction that will
this
close
final
the
result is just some transaction, right? This final result of the channel.
Basically, the commitment transaction should do only one thing: make sure that money are spent from the multi-sig account in worst case scenario. If someone will lose a computer, if someone would like to cheat you, and right now there's one possible type of commitment transactions, but there can be different types of that. Maybe in the future, if some new types of transactions will be introduced in the Bitcoin network, maybe even smarter will be invented. So the funny thing is that everything is in the Bitcoin. There are still a few missing parts. Not everything is already implemented in the Bitcoin, but we'll get to that.
So can I have a question at this point? Okay, so before you publish anything, only the first two transactions are known to the network. Like Alice owns 5 and Block owns 5. This is known to the blockchain.
Yes, this is at the beginning. Someone needs to fund this common account.
Yeah, but if I try to cheat here, let's say we do this and I'm Bob, and then I declare to give my 5 to Alice. So we'll create those later on transactions. And she will have like 10, I will have 0, but now I will spend my 5 bitcoins from the real network, and she will end up with 5, not 10, right?
We have few ways to prevent all those kind of situations. I'll try to explain all of that. Basically,
So you could, unless those bitcoins are locked in some.
in worst case scenario, if someone will try to cheat you or will disappear from the network, in worst case scenario, you can lose your Bitcoin, access to your Bitcoin for a particular time. For example, if you, in the commitment transaction, exactly here, we should have information for how many blocks we would like to lock Bitcoin in our channel. If we agree that this will be just 10 blocks, then in worst case scenario we lost access to your Bitcoins for those 10 blocks. There are few reasons why short or long period is good for certain type of channels. But basically, in worst case scenario you lost temporary access to your Bitcoins. But this is not the big problem in most cases. So I'll try to go further, and I will try to not screw this up because this is tricky. Okay, but before that, we need to remember that basically there are always two commitment transactions. One is in possession of Bob, another is in possession of Alice. And in most cases, this don't make much difference which is sent to the network. Both this is like guarantee that you can receive your bitcoins. Okay. Okay. So what we will try to do here? First, we have our common account with 10 bitcoins, and we are sending 6 bitcoins to the Bob. So if we have at the beginning 5 and 5, so this actually means that we send 1 bitcoin from Alice to Bob, right? Because at the beginning was 5 and 5, and right now we will have 4 and 6. 6 for the Bob. So basically this means that Alice is buying something. So at the same time, Alice is interested to actually make this transaction because she wants to purchase something, right? So this part is easy. This should be reversed, but we'll try to handle that anyway. This part translates to let me think. Okay, basically at this here we do not have any additional requirements. Just Bob's signature is needed to actually unlock this. So if this transaction will be broadcast right now, if with all those fields filled in, then thanks to this part, Bob will end up with 6 bitcoins at the end. So from Bob's point of view, this is okay right here. But Alice would also need to make sure that she receives own bitcoins. But at the beginning, those 4 bitcoins, what like the rest, is sent not directly to Alice, but to the common account. But with additional requirement that Alice needs to wait 1,000 blocks. Another thing, this is easier to explain if we are performing second transaction in the channel, because or n, because some part of preparing next transaction is making sure that old commitment message is invalidated, right? Because, for example, if Alice will end up with 4 bitcoins at the end of this transaction, she is incentivized to cheat and commit previous state when she owned 5 bitcoins, right? So she would like to cheat and send old commitment transaction because according to old commitment transaction, she will have 5 bitcoins. But because we are doing smart thing here, she will have a difficult time even trying to do that. Why is that? Because Bob makes sure that this can be spent to Bob if he knows old secret. And from where he knows old secret? When they Bob together with Alice, when they making another transaction, Alice needs to provide to Bob old version of the password. So Bob will have a way to enforce the transaction, even if Alice would not try to commit old version of the commitment message. And in that case, if Alice would like to cheat, then she will lose everything, because then Bob will also receive those 4 bitcoins. So if you would like to cheat and you will be red-handed, then you lost everything. Will be what is your in your channel. But you may say that transaction you can broadcast to whole network in case if any all commitment transaction from Alice will be broadcasted, please invalidate it for me. I will share with you some percentage. So basically, there can be multiple services on the internet which will help invalidate attacks in case of attempt of attack by Alice. And still, Alice will have to wait additional time. So if you are not certain about whether you trust Alice or not, you can always pick longer time, right? Even a year or something like that. If everything works correctly, then this is not a problem, this lock time, because you always share all secret with with your partners, so or Alice with the Bob and Bob with the Alice, so they are able to spend those money if everything is okay. So that was my attempt to explain Lightning Network. For me, that was really complicated when I tried to perform this and figure out what is the proper order of making signatures, providing hash to or secret. But basically, that would be more or less all. But basically, this is only about making direct transactions, right? Alice to Bob. And if you will be interested, I can try to introduce a little bit more complex version of that, where actually you have intermediary some in the between you, and you can have basically you don't need to have direct connection between Alice and Bob to actually perform operations. Basically, that will be all. Majority of this presentation is based on this article. I tried to animate it and explain things which were missing in that article. And if you would like to know more about, learn more about Lightning networks, those links would be very helpful for you. Basically, that would be all. Do you have any questions?
Have you seen the Sprites paper by Andrew Miller, where he and his team figured out a way to lower the amount of time that collateral has to be locked up for?
No, I didn't.
Yeah, it's definitely worth reading. Okay.
Thank you for finding this out.
I have a question. So is this already in use? So companies are using, some businesses are using it? Or?
Right now, this cannot be deployed on the current version of the Bitcoin network. The reason for that, there are a couple of reasons. First of all, first thing we need to be fixed in the Bitcoin is the malleability issue. Right now, maybe you are aware that there are two attempts to introduce new features. One is Bitcoin Unlimited, which is just about creating, maybe not just about, but about creating bigger blocks. And another thing is SegWit or segregated witness. And this segregated witness is fixing a problem with malleability. That was about a way to the exchanges had a problem that they tried to make sure that a certain transaction is broadcasted by taking a look on the certain parts of the transaction which actually could be changed before validation. This fix is required, so SegWit is required, and also a few additional opcodes, additional types of transactions. One of them would be, I try to go back a little bit. I mentioned that those transactions need to be prepared first before this one. Right now, this is not possible. You always need to know the parent, right? And additional opcode is required for that. And if I remember correctly, also lock time, relative lock time is not implemented yet. Everything has prepared Bitcoin proposals, BIPs, but we are still certain things still need to be done. But where this can be tested on the Bitcoin testnet, their segwit is already deployed, and there this can be tested. And also a lot of some people from the community have hoped that maybe even if this will not be accepted, segwit will be not introduced to Bitcoin in the first place, maybe Lightning will show the possibilities of the Lightning network. Probably whichever altcoin will introduce Lightning network to all network, probably this network can benefit somehow from that. But this is not the financial advice. Okay.